Hello learners, welcome to my YouTube video. Today I'm trying to code a program for a rectangular waveform with 4 milliseconds on time and 1 millisecond off time. At the end of the video, I will tell you how to make a similar program for 6 millisecond on time and 2 millisecond off time. The 4 millisecond and 1 millisecond indicates the delay which has to be given. So first we have to create a delay subroutine. It is enough just to create a single delay subroutine for 1 millisecond and we can call the same delay subroutine 4 times to create a 4 millisecond delay. For 1 millisecond delay calculation, please check the description box. So after calculating, we get the TH and TL value as FCH and 18H for 1 millisecond time delay. So now let's go to the delay function. The delay function is the one I'm highlighting right now. So it is given a label DLY. The instruction MOV tmod comma hashtag 10H means we are using timer mode register tmod in 16-bit timer mode, and I'm here using the timer 1. The back is again a label for the instructions here. MOV th1 comma hashtag 0fch means we are loading fch in higher byte of timer 1. MOV TL1 comma hashtag 18H is lower byte of timer 1. So these are the values which we obtained for 1 millisecond but after calculating the delay. Then the next is set B TR1. Sets TR1 is equal to 1, that indicates timer 1 is on. Then again is a label. J and B TF1 comma again means we are performing this operation again and again until the timer rolls over, which is checked by using the TF flag. We are using TF1 because the timer flag for timer 1. Then CLR TR1 is TR1 is equal to 0, which stops the timer 1. Then CLR TF1, which means we are clearing the timer flag 1. RET returns to the calling function where we have called this delay subroutine. So let's go to the first lines of the program. The first line is CLR T0.7. We are clearing the 7th bit of port 0 in order to enable the display where our output rectangular waveform will be obtained. Next is start MOV A comma hashtag 0FFH. Start is just a label. We are loading the data 0FFH which indicates high, that is on time. The instruction MOV P1 comma A tells us to load the value of accumulator to port 1 so that we can obtain a wave on the display. The instruction called delay, that is called DLY, tells us that we are calling the delay function. So I have given it 4 times because I want a delay of 4 milliseconds in the on period. Then we have the instruction MOV A comma hashtag 00H. This tells us that we are loading 00H, which indicates off time period, to the accumulator. Then instruction MOV P1 comma A is where we load the accumulated data to port 1 again. So we are calling the delay function using call DLY. Here I am using call DLY only once. That is because I want only a 1 millisecond delay during the off time period. That is, I want it to be off only for 1 millisecond. Then JMP starts indicates that we are giving an unconditional jump to the start function so that we can obtain a continuous rectangular waveform. Okay, I'm going to update the frequency to 10 so that it will be easy for me to explain. So I'm going to run the program and click on scope, and you can see that in the high it will run till it reaches 4 milliseconds here. Note that it won't change exactly at 4 milliseconds because we have few instructions which are given below before delay so that those instructions also require some time for execution. But our rectangular waveform will be running only for 4 milliseconds in the on time period, and in the 1 millisecond it will be going low, which you can see here. Now it's gonna change from 3 milliseconds to 4 milliseconds. So when it changes to 4 milliseconds, you can see that it is going low. This will run till 5 milliseconds. That is around 5 milliseconds. So again, you can see that it has gone high. So when you're showing the output, you can better use the updated frequency to 100 so that you can see a continuous waveform running. So I'm going to pause the program now and make few changes in the same program so that I can create a delay for 6 milliseconds in the on time and 2 milliseconds in the off time. So I'm going to reset the program and then I'm going to call delay 2 more times. Because we have already called it for 4 milliseconds, I'm going to make it for 6 milliseconds. So totally there are 6 delays in the on time, that is for 6 millisecond in the on time, and for the off time I'm going to give another delay, that is for 2 milliseconds. So I'm going to run the program to show you the output and click on scope. You can see that it will run till 6 milliseconds. And now you can see that it has changed to 2 milliseconds. Then again it goes high and low. It keeps alternating between high and low. You can even change the delay by giving different values by calculating delay for 2 milliseconds, but I have used only 1 millisecond delay. You can even use two delay functions and then call it once during the on period or off period. But this makes the program more simple. So I've used only one delay function in my program. So now I have given inputs based on what I have learned. If you also got the output, please like and share my video. Subscribe to my channel for more videos. Thank you.